Have you ever thought about the most incredible light show in our solar system? It's this moment when the sun, the moon, and the Earth line up in what seems like an impossible, perfect cosmic dance. So, how does this even happen? Let's break down this amazing cosmic coincidence together. Just look at this. What you're seeing is one of the most awe-inspiring sights you can witness from Earth. This is the moment a total solar eclipse kicks off, creating this brilliant diamond ring in the sky. It's a fleeting, absolutely jaw-dropping spectacle that people have been amazed by for thousands of years. And the whole thing hinges on a truly incredible coincidence.
Okay, so this is where it gets really wild. The sun is, well, it's gigantic, about 400 times bigger than our moon. But in this amazing twist of cosmic fate, it's also about 400 times farther away from us. From where we're standing here on Earth, that makes them look almost the exact same size in the sky. It's this perfect matchup of size and distance that lets the moon so perfectly block out the sun.
So that brings us to the big puzzle, right? We get a new moon every single month. That's when the moon is between us and the sun. So, shouldn't we get a solar eclipse every month? Why are they so rare? That's the mystery we're going to solve right now.
To figure this puzzle out, first we need to understand the cosmic racetrack our planet is on. You can think of it as this big, flat, level plane that Earth follows on its path through space.
That racetrack is called the ecliptic plane. Honestly, the easiest way to picture it is like this. Imagine the sun is a lamp in the middle of a giant, perfectly flat tabletop. Our Earth just travels in a circle around that lamp, always staying right on the surface of the table. That flat surface, that's the ecliptic plane. Okay, so the Earth is on this flat celestial tabletop. You'd think the moon would be on that same flat plane too, right? Well, it's not. And that little secret, that tiny little tilt, is the crucial clue that solves our whole mystery. 5 degrees. That's it. This one single number is the key to why eclipses are these special, rare events instead of just a monthly thing we get used to. So here's the deal. The moon's orbit isn't flat on that same tabletop we talked about. It's tilted, just slightly, by 5 degrees. What that means is, as the moon orbits the Earth, it actually spends most of its time either a little bit above that tabletop or a little bit below it. And boom, this diagram is the aha moment. Just look at it. Because of that 5-degree tilt, most of the time when we have a new moon, its shadow gets cast out into empty space. It completely misses us, passing either above our planet or below it. For an eclipse to happen, the alignment has to be absolutely perfect. The moon has to be crossing that flat plane at the exact right time for its shadow to actually fall on the Earth. Now that we know why an eclipse is even possible, let's talk about what it's actually like to be in the moon's shadow during the most dramatic show of all, a total solar eclipse. You know, the moon's shadow isn't just one big, dark blob. It has 2 parts. If you're lucky enough to be standing in the umbra, that's the dark inner core of the shadow, you get to see the sun completely blocked out. That's a total eclipse. But if you're in the much wider, fainter outer shadow, called the penumbra, you'll only see a piece of the sun get covered up, a partial eclipse. Experiencing totality is just, wow. It's this rapid-fire, breathtaking sequence of events. First, as the last sliver of the sun vanishes, you see something called Bailey's beads. That's sunlight literally peeking through the rugged valleys on the moon's edge. Then, those beads merge into one last brilliant flash of light, the diamond ring. And then, totality. The sky goes dark, and the sun's magnificent, ghostly atmosphere, the corona, just pops into view. You can see that incredible progression right here. We go from those first moments, like Bailey's beads on the left, to the sun being completely hidden, which lets that ethereal corona shine in all its glory on the right. It's a switch that flips in just a few seconds, but it's something you will never forget. But hey, solar eclipses are only half the story. There's a whole other kind of eclipse, one where our own planet is the star of the show, casting its huge shadow out into space. A lunar eclipse is pretty much the opposite of a solar one. This time, we're talking about a full moon, and the Earth passes directly between the sun and the moon. The moon then sails right through Earth's shadow, dimming down and often changing color in a really dramatic way. So why does it turn red? You've heard of the blood moon, right? Well, think about this. As sunlight passes through Earth's atmosphere, all the blue light gets scattered away. That's the same reason our sky is blue. What's left is all the red and orange light, and that light gets bent, or refracted, straight into Earth's shadow.
So during a total lunar eclipse, the moon is being lit up by every single sunrise and sunset happening on Earth at that very moment. How cool is that?
This beautiful image shows you the whole thing. You can see the moon slowly entering Earth's dark shadow, the umbra, making it look like a bite's being taken out of it. And then it gets completely swallowed up in that coppery red glow of totality. Okay, let's do a quick recap of the big differences. For a solar eclipse, you need a new moon, and you have to be on a really narrow path on Earth to see the moon's shadow. And, this is critical, you need special safety filters to look at it. For a lunar eclipse, you need a full moon, and pretty much anyone on the night side of Earth can see it, as our planet's shadow covers the moon. And best of all, it's totally safe to view with your naked eye.
Now, while these events might seem like they happen at random, they are anything but. Ancient astronomers actually figured out that eclipses happen in a grand, predictable pattern, a celestial rhythm that repeats over generations. And this rhythm is called the Saros cycle. It's a period of just over 18 years. After that much time has passed, the sun, earth, and moon return to almost the exact same geometric alignment. This allowed ancient civilizations to predict when a very similar eclipse would happen all over again, which is just a remarkable feat of observation. This map just illustrates those predictable paths so perfectly. Each line here represents the narrow track of the moon's umbra during a solar eclipse. You can see how these paths crisscross the globe over the years, which really shows you why each one is a unique, can't-miss event for the people who chase them. And all of this brings us right back to you. The cosmic coincidence, that 5-degree tilt, the Saros cycle, it all leads to these real events that you can witness for yourself. A major total solar eclipse is coming to North America very, very soon. So, now that you understand the incredible celestial mechanics behind it, the only question left is, where will you be to see it?